Hi, my name is Brandon Sand. I'm here presenting my CAP1 project, aka the breakdown of glucose, fatty acid, and how the pathways really connect with each other. I'm here in my home office, aka my bedroom, so that is why I have a TV behind me and other things. So first start off, we want to understand thermodynamics, or the first law of thermodynamics, which ends up being energy cannot be created nor destroyed. Energy is always just transferred from one thing to another, aka or potential to kinetic energy. The best way that it's done this, or that it's done this way, is ATP is broken down into ADP, an extra phosphate, and energy. And then that extra energy is then used for creating more ATP. And there's a cycle that continues to keep on going, so the body can continue to keep moving and continue to keep getting more energy and living. So first we need to understand that kind of basic thing before we really dive into anything else. So let's go to the breakdown of let's see if I can get this to work. Perfect. Breakdown of a glucose molecule. So for glucose, we first go into glycolysis. I'll go ahead and dive deeper into anaerobic and aerobic glycolysis. Anaerobic meaning no oxygen, and then aerobic means with oxygen. But first, we're just going to say glycolysis. We use 2 ATP to help start that glycolysis process. We net a total of 2 more, or 4 total. Net a total. I apologize. But then we also get 2 pyruvate molecules. We also have these transport chains down here, or transport molecules, or enzymes, stuff that continues to keep this process going. Once we get to the 2 pyruvate, we have more of our transport molecules, which helps us with this 2 pyruvate, help releasing CO2, as well as creating 2 acetyl coenzyme A molecules, or acetyl-CoA molecules. Those 2 acetyl-CoA molecules will then be put into the citric acid cycle. And we see a lot more of our transport chains. So we yield a total of 32 ATP from breaking down one glucose molecule. So now let's go on to our palmitic acid, a 16 carbon chain fatty acid. So first, we go through 7 cycles of beta oxidation. That's 7 cycles of beta oxidation will create 8 acetyl-CoA molecules along with 7 NADH and 7 FADH2. The acetyl-CoA will then go back into the citric acid cycle, yielding us 8 GTP, 8 FADH2, and then 24 NADH. And all of these will then be used to the electron transport chain, which then helps create our total of 106 ATP being produced from this. So for this next slide, I don't want it to mean what it's saying on here. I wanted to show you a good use of how they intermingle, because it's not just we break down one glucose molecule and then the fatty acid breaks down over here. We got our glucose on our left, or I guess it's your right, my left, and then it over here. Everything intermingles together, and it's all done at the same time because the body works together in so many different ways. It's incredible. So now we have I'm going to go back to this slide here. We have interact with each other. So first, we have 3 energy pathways on how we use energy. Our first is our phosphocreatine. That's about our first 7 to 10 seconds of energy usage. That energy is then used to start up anaerobic glycolysis, which then produces pyruvate and lactic acid. And that's around that energy system we use for the first, after that 10 seconds, it's 2 to 3 minutes. And then after that, we go into our aerobic glycolysis, which then helps filter that lactic acid back towards the heart and then continue to create the ATP needed to continue to move, do our exercise, continue to keep living. So, one way I wanted to show that on how it works in real world is like an elite 800-meter race. So some of the best 800-meter runners, I'm not sure what the exact record is right now, but let's say they can run a 150 to 2-minute half mile or 800 meters. So first, in a race, you want to start with sprinting, then you go into speed management, and then you end sprinting again. So for that first 7 to 10 seconds, you use that phosphocreatine, which is our initial energy store. And then we go into our anaerobic glycolysis because that's that 2 to 3 minute range. So we should finish that race at that between that 2 to 3 minute range. Then after that, to help continue the body so it doesn't get incredibly sore and everything else, we need to do a cool down of like 5 to 10 minutes. That's why you see, if you were ever at a track meet, the long distance runners tending to continue to keep running after they finish their race. It looks bizarre, and I was one of them. So I didn't like it, but that's what we did to help feel better so we can continue to keep racing and continuing to perform. All right. So now we know how it kind of works in the real world. Now, why can't we just use the palmitic acid breakdown? We put very little ATP and we get 106. I mean, that's a lot more than just 32. Well, when it comes to breaking down stuff, we don't initially want to break down the biggest thing because that takes time, that takes a lot of energy, and we can't quite use that anaerobic glycolysis to do that. Because initially our body wants to use our smaller energy sources, our quicker energy sources, instead of just going straight for our fat, like fatty acids. The body wants to use carbohydrates, the easy glucose. So that's why we start with phosphocreatine, initial energy source. Then we go to anaerobic glycolysis and then aerobic. So that's when we start introducing oxygen back into the body. So let's see if we have kind of covered everything. We can go through it again if we'd like. So this first one is the first step between glucose and pyruvate is our glycolysis. Then between pyruvate and acetyl-CoA is pyruvate oxidation, and then going into that will be into our citric acid cycle. We have a total from a glucose molecule, we have our 32 net yield. Then we go into our palmitic acid, we have a 16 carbon chain, 7 cycles of beta oxidation, we get a total of 106 ATP from that. Then we kind of see how they all intermingle. We understand that we use our phosphocreatine, then we use our anaerobic glycolysis, then aerobic glycolysis. The body does not want to use oxygen unless it has to. And then here are my resources. This first resource was for the middle slide diagram. The second one was for the first and the third. I ended up, this first one I used for the initial breakdown, but I had to modify it because it was an 18 chain fatty acid. So Thank you very much.